We begin with slope, and we just need you to know a couple things about slope, I guess. So typically when you think of slope, right, you've got a graph, and a slope has to do with a couple of changes. So if this point was some x1 and this point was some x2, and similarly if that point was some y1 and up here y2, then we talk about that slope being the change of the ratio here, that change. And that change we get by looking on the y-axis, and we see y2 minus y1. And this change, and we look here on the x-axis, and we see that that change would be x2 minus x1, according to this. And so we want to look at that ratio, and we call it slope. And that ratio of y2 minus y1 over x2 minus x1. Okay, now we want to do a couple things here that are a little bit different. Now, so as we look at that, we talk about change. Well, we use Greek delta. Okay, so an uppercase delta. So it's a Greek upper case delta. I was going to make a delta again. Okay, so we use a Greek uppercase delta, and for change. We use that for some other things as well, but so we look at this, and so what we would say is our slope, which we usually call m, so we'll say slope m is, and what you have seen is change in y over change in x. Now, something I want to do that is a little bit different is to start using f of x function notation. And let's see, before we do that though, we can multiply both sides by delta x, and I could write this as the change in y is slope times the change in x, and that's an important relationship. So we want you to think about slope as the ratio of the change in y over change in x, but we also want you to think of the change in y-axis, that we could describe that by taking the slope times the change in x. Now, so if we go to function notation, the idea here is we want you to get very used to this, because in calculus, function is very important. So function is very important in the big C, calculus. Oops, if I can spell it right. Okay, so yeah, very important, and so we want you to get used to that idea of function, and functions, of course, are just any sort of relationship between one variable, and usually we say x, and another variable y, and we think of that as it's a relationship for which for any given x, if there is a y that goes with it, so for any given x, if there is a y that goes with it, okay, then there's only one y that goes with it. Okay, so this is this y is the only possible y that could go with that particular x value, and so we see shapes like that, but you know, so this is a function here, but this is not a function. You know, if you see something like this, okay, and there's x and there's y, okay, this is not a function because, oops, because if I look at a particular x value here, there's a y value there and a y value there, and so that's a problem. Okay, so that's not a function. In calculus, for the most part, we do everything with functions. Now, later, you know, as you get into things like calculus 2, maybe calculus 3, you might deal with curves that look like this one on the right over here, but actually the way you deal with them, you still deal with them in terms of functions, and so, you know, really calculus, we need this idea of function. And so here, instead of always thinking of, oh, here's a point x, y, we want to think of it sort of as the function pair, you know, f of x and x. So I have an x value here, and then this is sort of the f of x axis over here. So y and f of x can be quite synonymous in many ways, but we want to start thinking about that function f of x. And so along those lines, I can take these two same relationships and write them with an f notation. It really doesn't look much different. You know, we can say that you know, the change in f over the change in x, we can call that slope, at least for a straight, you know, for 2 points, as we look at that. It's still the slope between 2 points. And then also think about this relationship of delta f, or change in f, is the slope times delta x. Now, in general, neither of these is true. Oops, sorry about that. My hand hits something on here. I still haven't figured out quite what I do that makes that happen. But you know, these aren't really exactly true. Okay. Not really true. Not in the same way of the notation up here, where we think of these, that y and x, as being from points, you know, an x1 and a y1, an x2 and a y2. Here on a general function, you know, I still can say, oh, I can take the change in f, you know, so there's one value of f, another value of f at different x values. We could look at the slope of that line or the slope between those 2 points. Yeah, we can do that, but in a more general sense, this isn't exactly true. Not really true, but we're going to end up using it for small cases. So not really true, but close if delta x is very tiny. Okay, so this notation, I want you to get used to thinking about this f notation, f of x, and the functions and all that. But to write these two things, you know, this one and this one, generally speaking, for a function, a general, you know, some sort of function, where I'm talking about, you know, something like this up here, then, well, these two statements aren't really true, but they're really close if we take delta x small enough. And of course, if your function actually happens to be a straight line, you know, so if that's your f of x function, oh, well then they are true. But if f of x is not a straight line, then these would just be something very, very close if x is very tiny. And that's where we're going with calculus. You know, that's what we want to do. But so I just want you to start thinking about the fact that we're interested in functions, straight lines, as long as they're not straight up and down. They are functions, and so they're just a special case. So straight lines are a very special case in which, though, this really is true up here, right? If those are straight line functions, then that is true. Okay, and in this first section that we're talking about, that is, you know, it is straight lines. So this will work for our straight lines. And I think that takes care of that basic relationship. And so we'll stop this video here.